Good morning. Welcome to lecture 37 on thermodynamics of materials. So we are going to take up today the solution for the first class test question paper. The first question is already written here. Find if the following statements are true or false, giving explanations. For n moles of a monatomic ideal gas, H by U, these are the given. H by U is function of temperature, H by T function of temperature, H by P is function of temperature and pressures. Find whether true or false, giving explanation. Yeah. So the answer is H by U, see for n moles, this is the answer n 5 by 2 RT over n 3 by 2 RT giving you 5 by 3, which is a constant, is not a function of temperature, hence false. And sometimes you have made some mistakes, I have noted. You have written dH is NCP delta T. What is this? This is differential, this is integrated expression. Differential expression cannot be equated to integrated one. It is dt. Or alternatively, both sides integrated is delta H, delta T. These are okay. Given this, given dH is NCP dt you have written, and du NCP dt, your argument is this is a constant, hence Hi by U, H over U is also constant. Let us see. dH by, I am writing, take up this. Or, see, your argument, dH is 5 by 3 du, I am integrating for you. Or your argument I am going, H is 5 by 3 U plus another constant. Constant, okay, second constant, okay, what's what I say, another constant. Plus, so is it H by U is 5 3? H by U is constant, H by U. H minus constant by U is constant. What is this? See my point? Or H minus constant, you have to take subtract. So see, don't take easy. By H minus constant by U is 5 3 is a constant. So that means this is not function of temperature. H by U where you are getting. Okay, you cannot, you should not. Okay. Moreover, these are the original errors, basic errors. DH is asked, question is asked on H. For such a simple system, we know. Normally, we know. For most system, we don't know absolute values. But this is such a simple system, we know. And use this. Thank you. Second is what? H by T. Now it is very easy for you. H by T is what? N 5 by 2 RT by T. T cancel, R is a constant, so is still a constant. N is a constant, N is not a variable. Oh, you have not got your, okay. Murmu has not got perhaps. It's constant, okay. It's constant, so is not, so false. Happy? Constant. N is a constant, remember. For n moles, n is not a variable, for n is constant, okay, so it's constant. Third, I'm giving you, let me finish this quickly. H by P, let us see. H by P is what? Again, N 5 by 2 RT by P. See now, don't cancel. N 5 by 2 extra constant is a function of T by, is function of T by P, means TP. True. This is the answer. 3 marks. Marks 3. Okay, this is. Chandrasekhar, yeah. Sabbasachi, roll number 34. Sabbasachi Murmu. Sabbasachi. You'll return your answer papers at the end of the class. Next question is what? Second part. This first part is over, 3 marks discussion. Second is what? Let me write first. Shall I remove this part? Second is saying, let us see. Second is what? Second question is, let me write that part 2. Check if the expression du plus PdV is a perfect differential. Is a perfect differential. See, 2 ways to answer this. Okay, what is this? 1, 2, 3. 1A, this is A. 1A, sorry, this is, I'm very sorry, this is A, this is B, very sorry, C. Now 2. Answer to the questions. du plus PdB, can you write in the form of d something? D what? Can't be written in this form. Cannot be written. Cannot be written in this form. This is the answer. Or that leads to what? It cannot be integrated without specifying any conditions. Freely you cannot integrate. Freely. You can integrate. If you try to integrate, so integrate like this. Since you cannot write this, so you cannot integrate also. Same answer. Same thing. If you integrate, this you will integrate easily. This PDB integration, unless PV relationship is known, we cannot. That's why what is a path function, not can integrate. Path dependent, a constant pressure, constant temperature, you can, constant volume. So you cannot integrate. Also, this expression can be integrated. Independent of the path. Recall, that's why very good. But note in contrast, this is addition and top, but it will be very good, satisfying answer, and some students have written perhaps also. Note, important to note, in contrast, see how. See, du plus PdV plus VdP, sir, is a perfect differential. It is a perfect differential. How? Let us see. It is a perfect differential. How, sir? Why? Because I am giving you. It is nothing but, sir, du. This is dPV. So this is nothing but dA. U plus PV. So perfect differential. And you can integrate also. If you integrate this, du is from 1 to 2. Oh, you can separately, you can integrate this 1 to 2, that is the next question. So this is 1 mark. Mark 1. Third is what? Can I remove this? I remove this, huh? This is over, all over. So remove all this. Let me write question 3. Question 3 little lengthy though, but don't mind. It is a given dH is du plus PdP plus VdP. Okay? Find the delta H of the system. Find the delta H of the system. Which is not an ideal gas. Because we are so used to ideal gas. This question is not for ideal gas. Any. This is ideal gas. Okay? Not mentioned anywhere. Nothing to do with ideal gas. It's a real gas also. There is a system which is not an ideal gas. Ideal gas. As it passes from state 1 to state 2. The following data supplied. Are supplied. Okay, quickly, very fast. What are the data supplied? Quickly, write. Shall I write? 1, 2, 3. And U1 is 30 joule. 30 joule. P1 is 1 atmosphere. V1 is 0.1 liter. 1 liter. U2 is 32, I'm sorry. 32 joule. P2 is 5 atmosphere, I believe. 5 atmosphere. And V2 is 0.08. 0.08. 08. Oh, this is difficult though. 0.08 liter. So quickly, solution. Okay, solution continued. Solution here. So 1, 3. 1, 3 this side. This is the question. Okay, very yes. What is this? Start. So given this, so you can do this way since you are instructed. So it is, as I have already discussed here, okay, is du plus dpv is okay. That's right. What is the integration? Integrate 1 to 2, state 1 to state 2, integrate state 1 to state 2, integrate state 1 to state 2. No problem. Shall I remove this? Unnecessary. Or what? This is known as, dH is known as H2 minus H1 delta H. Same. Delta H is what? H2 minus H1. No? This is what? H2 minus H1. But delta H is asked. Find delta H. Is what? Here you write U2 first term. Delta, since delta is not given, absolute is given. Go by the absolute. Delta U is given, use delta U. If given U1, U2, write U2 minus U1. Okay, simple minded. Plus, what is this? PV2. PV2, this is a PV2 minus PV1. What is this? I write here. What is this? P2V2 minus P1V1. PV2, state 2 is P2V2. P1V1. So substitute. Given all value given, you get this. What answer? Quickly. 32 minus 30 joule. There is another snack, small. What is P2V2? P2 is what? If you write this, P2 is what? 5 times 0.08. I am writing for you. Minus P1 is, P1. This is here. P1. P1 is what? 1 times 0.1. Happy? 1 times 0.1 liter atmosphere. Put the unit. This is liter atmosphere. So liter atmosphere, good idea. So right here 2 joule plus you get this out is 0.3. 0.4 minus 0.1 is 0.3 liter atmosphere, but they will not add different units, convert same unit is 101.3 joule per liter atmosphere. That is the conversion. So actually liter atmosphere cancel, remaining joule. What is the answer then? If you do this, 2 plus 30.39 is 32.39 joule. Answer. How much marks was given here? Third marks here. Marks is 7. Okay, 4 marks. For shall I write here? Marks. Okay, I don't have space there. Marks 4, third part. This is your total 8 marks. See how difficult it was. You judge yourself. 8 marks was actually up for grabs. Easy. Okay. So this is over. Next question is question 2. Can I remove this? Quickly, very quickly. Question 2. Start. Question 2. Start. Do you have fencing here? Fencing here. Question 2. Let us see 2 moles of a monoatomic gas. 2 moles of a monoatomic gas. Atomic gas is with the molar heat capacity, with the molar heat capacity which you know already, but given molar heat capacity is known as Cp. Careful, they have little capital. This is actually, don't worry, you know molar. Cp, okay, total is 5 by 2 R. 5 by 2 R. Cp is 5 by 2 R. R initially taken in a closed system, at 600 Kelvin and 3 atmosphere pressure. At 600 Kelvin and 3 atmosphere pressure. The gas is then irreversibly and adiabatically expanded against 2 atmosphere, expanded against 2 atmosphere external pressure. To the final volume V2. Find V2. How many marks? This is 10 marks. 10. So remove this. Question 2. First of all, I tell you what is the situation. See, if you want to sketch that, your favorite sketch, just in case you are interested, just state 1. Equilibrium. State 1. State. What is this? N moles. How many moles? 2 moles ideal gas system. Just in case you are interested. And so sketching the problem. What is the pressure? Initially, what is the pressure? 3 atmosphere. Temperature is what? Temperature inside is 600 Kelvin. Moles given, volume we can find out. We will find out. State. Then it is adiabatic. Insulated from the surrounding. So it is known as adiabatic condition. How you carry out this process? Reversibly you can carry out. 3 minus dP, 3 minus 2 dP, and goes on. Okay, this to the final pressure. 3 atmosphere. Then what? But this is not you have done. You are irreversible. So suddenly knock it off and give the pressure of 2 atmosphere. So irreversible. Finite driving force. This is the sketch. So start. What is this? If you want to sketch it in here, sketch this PV diagram. PV diagram very important. This is the experimental sketch. Okay? PV diagram is what? Start. See, I am actually giving you, so what is the starting pressure is what? 3 atmosphere. 3 pressure is atmosphere. And this is suppose 2. So what it is doing, I tell you what. Suppose I am just drawing friendly, this 3 atmosphere line, this is 2 atmosphere line. Okay. 3 atmosphere, this is 2. So if you are reversible for contrast. What reversible will be, this is, I should actually show, no problem. This is friendly because reversible is not the concern. But here, so this is reversible adiabatic. Will be, I call it 2 prime. This time not 2. 2 prime. This is reversible adiabatic for for comparison. This is not required. You may not draw this reversible adiabatic. But this is irreversible adiabatic. So you know very well. It is, I am giving contrasting color, and must be dotted. Must be dotted. So right here, state 1. Right here, state 1. State 1 to state. Okay. Drop, 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 drop. Suddenly, then, oh, I wanted to give this. So, okay, don't worry. Since I have started, let us start. It will not stop here. Because in adiabatic, path affects the state, final state. Path affects the final state. So, final state will be different. This is your 2. Find V2 and V2. Okay. So, one state is equal right here, 3 atmosphere, and temperature is 600 Kelvin. V2. This is the V2. Find V2. Okay. Remember, note, if you have forgotten, note, in an adiabatic process, path affects the final state, or the reversible or irreversible. Path means reversible or irreversible. Path affects, right here, reversible or irreversible. Reversible or irreversible. Okay, irreversible affects the final state. In short, path affects the state, but okay, explicitly affects the final state. As you have seen, no doubt, final state has been affected and has been different one with the volume V2 and corresponding temperature T2 and pressure, of course, 2 atmosphere. So, but 2' is the reversible endpoint. So, what is this? Quickly start. So, in this solve this problem, find V2. You start since first law. Q is delta U plus W in the finite change mode. Q is 0 adiabatic, or W is, actually, let me, the way I have done, let me do this, I'm better, okay, right, or W is, because I have to go fast. What is the W? Remember, this W is actually P external dV, since this is, so this will be actually, if you follow, this is actually, if you ask me dV, you will still ask me 1 to 2, state 1 to 2. I'm writing for you. And what is minus delta? Delta U. So V2, this is V2, and temperature is at state 2, temperature is T2. Okay, right? Somewhere right, will you write there? At state 2, this is, state 1, sorry. So this went up to where? This is your, sorry, it must expand. State 2. You write here also, you can write here. State 2 is what? P2 is 3 atmosphere, or very sorry, 2 atmosphere. 2 atmosphere and temperature, volume are both unknown. Okay, state 1 already you can see, state 1 is given, I have given here, 3 atmosphere, 600 Kelvin. Quickly, so I have done actually, I am coming to this. P external dV, ideal gas, NCV delta T. No one can stop. NCV delta T. No one can stop. Delta T, final minus initial. Or here, NCV dt, you want to do this. NCV dt integration 1 to 2. No problem. Anything is will do. P external is here. The work is done here. As a constant. It is not a constant pressure process. It is a variable process. 3 to 2. This is not constant pressure process, but the work is done against the constant. This is the idea. So P should be taken outside, as we know, P external. Write nicely V2 minus V1. And you do this here, NCV minus NCV, or NCV rather, absorb minus NCV. These are all temperature independent. T2 minus T1 becomes T1 minus T2. You are all set here. You know what is the difficulty. You know very well what is V1, you know. NCV all known, T1 you know. T2 V2. T2 V2 3, T2 V2, actually you will try to get this. See, V2 you can find here from the V1, V2, V2 T2 relation you will get from this. Okay, quickly let us do this. Okay, so but V1 is, V1 and this is on V1, this quickly, V1, quickly, V1 is State 1, NR, T1, state 1, equilibrium, P1, V1, or V1 is what? NR T1 by P1, quickly substitute 2 moles, R is what? 0.082 liter atmosphere, T1 is what, sir? Temperature 600 or what Kelvin, initial temperature is what? 600 Kelvin, okay, can this liter atmosphere, P1 is what atmosphere? 3. You write this, I prefer writing, not avoiding Kelvin. You write here, this you are liter atmosphere, then it makes sense, because this is mole, liter atmosphere per mole, okay, R is mole per Kelvin, okay, so you know mole Kelvin, okay, don't mind, this is the R unit, okay, and this is N is what? Mole. So cancel, all this cancellation effect, if you do this, answer is, you know very well, 32.8 liter, one thing, one interesting thing, okay. So please substitute or continue. P external is what? So tell me, okay, what is this? P external is what? 2 atmosphere. V2 is what? V2 is the unknown stuff. V1 is what? Okay, V1 is what? Tell me, 32 a moment ago, 8, you give liter, bracket, another bracket liter unit is what? Let me write, N is what? 2 moles. If we mask actually, I am very, okay, okay, this, okay, meticulous. Cv is what? 3 by 2 R. Cv I am writing here, Cv is what? What is that gas? Monatomic, 3 by 2 R. So substitute directly, 3 by 2 R, R is 0.082. I am writing this unit, you can do T1 minus T2. What is the T1 minus T2? T1 is the 600 and T2 is the unknown. T2 is the unknown, okay. V2 minus T2 is the unknown, okay. So you get this. But what is the relation between V2 and T2, okay. Now, okay, I'm very sorry, okay. I'm trying to take these things, okay, you're right. Okay, this, can I remove this here? Where it is? Remove this. Well, do this, continue. Or 2, I'm writing, sorry, you understand, 2 V2 minus short, 32.8 is, these 2 cancel, 3.082, 600. What is the T2? Please tell me, T2 here. T2 here, see, here, from here is better. Shall I write here? T2, state 2, refers to state 2, is equilibrium state. Final equilibrium state, right here, this is the equilibrium state. This is at an equilibrium. This is, state 1 is the equilibrium state. Oh boy. Equilibrium, right, I got one. Equilibrium state. Okay? Equilibrium state. What is this? These are non-equilibrium. These are non-equilibrium, 2 non-equilibrium states. Okay, good boy. So quickly, what is T2? So it is state, right? T2 is what? So T2 is what? NR2. You know this now? NR2, P2, V2. All you know, or you don't know. P2 is how much? What pressure? P2? 3. What is 2? 2 atmosphere. 2 times V2, NR is 2, R is 0.082. This gives you a connection of V2 and T2. See, V2 and T2, one connection, another connection. V2 to this is the process. So you express V2, T2 in terms of V2. So don't keep 2 unknown, one unknown here. V2, T2, one unknown, not 2. So V2, T2 is what? Then it is 0.082, or T2 is what? T2 is what? So if you substitute this, V2 is, what is this? 2 to cancel. So you get this relation. What is the relation then? T2 is P2, V2. Achha, let me write P2, V2. So I write this. What is this? V2 by 0.082. No? V2 by 0.082. Write that. I'm writing 0.012. About roughly 12. 600 minus V2 or T2 is here. T2 substitute T2. So all V2. Only one unknown. So V2 you can solve this yourself, or can I do this? I get you 200. One mistake is here. Okay, so not mistake actually. I'm sorry. I'm writing actually 0.02 is suppose I'm sorry. It is CB 3 by 2 R. You can write this. Okay, you can write this, or 8.3. Suppose 8.314 joule if I write. the whole thing is joule, then what we change have to be liter atmosphere should be multiplied by 101.3 or liter atmosphere both sides. That will do. No problem. This is 0.08. This is 0.082. This is also where it is, where you have used 0.082. This is already liter atmosphere, so don't have to change. That will do also. Or you may consider. Or you prefer this 0.082. That's because actually CB actually normally I write 3/2 R. Joule, liter atmosphere. Not used to use this. The CB is what? CB is joule per mole per Kelvin. Okay, so liter atmosphere, I have given this, but this side is what? Liter atmosphere. So multiply by 101.3. The explanation I have already given the explanation. Or you give it this value 202.6 V2 minus, do this, anything you can do. So you can write 0.082, no problem. Absolutely no problem. Then don't multiply by this. Actually, they have noted 8.314 divided by 101.3 is 0.082. This by 101 is 0.082. See, either you write 0.082 or you give prefer CB. Actually, I prefer joule. Actually, liter atmosphere work I use. Then convert into joule. So here 8.314. So this liter atmosphere should be converted. Okay, either I remove this, then make it 0.082. Same I have done. 20, it is up to no problem. 6645. You check the calculation. 3 into, I have written here. 3 into, I bet here, change. 8.314. Yes, here, I have 3 into 1 point, write that out. 3 into 8.314 into 600 minus this, okay? So this is actually, this result is what I'm writing, this result. Do this. Achha, you have any difficulty here? T2, V2, here, 0.082, why? 0.082, this is liter atmosphere. So this must be this, okay? I'm giving this result. Multiply 6, 48 and 3, 144, and you get this 14965. And 2 zeros, 14965. Do this. And next step is what? Tell me. 304 V2. 304. This is actually roughly 12. By 0.082 is 12. And times actually is 24. 12 is 300, close to 300. So you can check the calculation. Or V2 is what? 506, 21,610 divided by what? Tell me, 506.6. You do this, 506.6, and then you get 42.7 liter. The answer. Okay, I can do this, This 304 and 202, 506, and if you take this side, it's okay. Any problem? No problem. It's absolutely easy, simple. Okay, what is the, see, this is the link, first of all. Link. V2 and T2 are coming, but V2, T2 are bound in this equilibrium state. This is the whole issue. So V2, T2 relation, and V2, T2 is bound by this state equilibrium relationship, PB is nRT. So this equation substitute. Can you find T2? You can find T2. T2 is this relation. So you can find also hot temperature. If you do, I did myself. If you do, I'm giving the answer. You can do yourself. If you substitute this V2 here, it will be 521. 521. Do you expect this? Of course, you expect it because that is adiabatic cooling, expansion particular cooling. Cooling will be there, but cooling is less than what would happen in reversible cooling. Okay, this okay though? So remove. Don't waste time. Last question. How many? 5 minutes. Over. So whose class? Okay, whose? Yes. Downstairs, no? No, it's okay. Okay. Oh, how long it is over? Oh, it's 11:30. So just this let me put. So initially, actually, I'm going slow. So we train you what to do. Okay. Question 3. Just I'll go fast little bit, but this problem is lengthy. Question 3, if quickly, in a proposed He proposed lead making process shall I talk with him? Basis? Do I have to talk? Basis, okay? I can talk to him, okay? What time will start? Can I ask him? Oh, you'll take time, 1 minute, okay? Solid. Actually, let us go fast. Solid, let's follow this. Lead sulfide and oxygen enriched water and oxygen enriched air. This question is important. I can direct? Writing. I have to write the question. Actually, not those who are following, they want to see what question it is. It can be done. Actually, I go faster. I understand your point. I actually understand. Are blown into a continuous. Are blown into a continuous. Okay, continuous reactor in a reactor in a stoichiometrically equivalent amount. Quickly, stoichiometrically equivalent amounts. Good, very good. Don't worry, not much writing. The products are. This is very challenging, little bit challenging problem. Okay, follow this. The products are liquid lead, not difficult at all. Liquid lead, and an SO2 N2 gas mixture. The reactor is maintained at 1500 Kelvin. The reactor is maintained at 1500 Kelvin. And the heat loss to the surroundings, okay, to the surroundings is at this temperature is estimated to be how much? 41.8 kilojoule per mole of lead produced. The input materials are at 298 Kelvin and the output materials are at 1500 Kelvin, obviously, or 1500 Kelvin. Okay, find. This is the, I am writing here. Find. Right here. It is better. It looks good. Find the. I'll give the data on the top. Find the extent to which the air must be enriched. That is 2 watt% oxygen. That is 2 watt enriched 2 watt% oxygen by mole. Mole percent means mole percent, not volume percent, by mole, so that no extra fuel, actually no fuel will be needed to maintain the process, to carry out the process. Maintaining at 1500 Kelvin and getting the desired product. Data given giving the data. Okay, I'm giving star here. I'm removing which one? Okay, I'm removing one. Okay, here data and star. This star, I'm giving star here. Star is better on this side. One by one. Standard enthalpies of formation. Standard enthalpies of formation. At 298K. At 298K. 3 are given. PBS how much? 94 kilojoule per mole. And what is the next? PBO minus 218 kilojoule per mole. Kilojoule per mole. And what is the last one? SO2. And SO2 minus 297 kilojoule per mole. This is the data about the standard enthalpy of formation. Another data is the enthalpy changes. Shall I take this, okay, this side, remove this, unnecessary. Almost done. Let me write this. Okay, what is data? And there is star, double star from this point. This double star, continue. Remaining data here. So another fencing here. Another fencing, let us see. What is data? Continue. Data, quickly. Enthalpy changes. Enthalpy changes. What is the change in the from H1500 minus H298? What is this? PB, how much? 40 kilojoule per mole. What else? PBO, 101. O2, 31. Who else? Nitrogen, 38. And last is SO2, 62. Achha, this is the problem. How many marks? 12 marks. Marks 12. Quickly, just quickly and very quickly. Solution. Solution, question 3. I tell you something, first of all. You read what is this adiabatic flame temperature. You read very well. Okay. This is adiabatic flame temperature problem. Nothing else. I am showing you. Just this I am trying to show you. Okay, here I am showing you. What you did? Adiabatic flame temperature, recall. Achha, I am writing this side, then I will remove this. Recall adiabatic flame temperature problem. AFT problem. Okay. Flame temperature problem. First of all, this I have problem. Discuss in the class. Discuss in the class. In the class. What is this? You have this type of arrangement, na? This is the Bunsen burner or gas stove. You are entering methane, the fuel, entering the one reactant maybe. One reactant, oh sorry, this is open channel. And you are entering here oxygen or air maybe, whatever. I mean, just giving you. And then it is actually lighted here. There is temperature here. Say temperature 2500 I said, roughly. This problem, what we did? We consider the reaction. Entering 298. Let us see. Entering 298, they are entering. What is the product here? You recall CO2 plus CO2 and H2O. Just balance. This product is what? SO2 NO2 gas plus liquid lead. We write that. Reaction I will write. You can write the reaction here. Lead, what we consider in this problem? Adiabatic? What? Recall. I am keeping a recall. Ask it. Q is, you follow? is delta H is what? 0. Like this way, right? This I think, no? No, it's okay. It's okay. Now what way you wrote? And delta H is Q. You wrote this. What is this? What is the constant pressure? What you did? Constant pressure. What is this? 0? Adiabatic. Perfectly, no loss. No loss. I said, but practically there is loss of heat. You stay at the burner, near the flame, they will be getting some heat, means loss to the surrounding. Some loss. Ignoring this, ideally, this is the answer, roughly. Okay, roughly this is the answer. This is solved. No loss. But today, if I say, if loss is there, you will understand this will not be 250 Kelvin. It will be slightly less. It will be less than that because loss is there. So, what is this problem? If there is a loss, put it here. Put it here. Loss is 0. Here, loss. This is the loss. It's 0 for adiabatic, perfect adiabatic. Perfect, quickly. No loss. Why? What is adiabatic? No time to exchange. The open, good, but so fast, no time to dissipate to the surrounding. And he is continuously doing, continuous, same, one stream coming, doing this and leaving. Again coming, leaving. So this is also continuous reactor, continuously flame is burning, continuous. So it is 0 loss. The loss, put that loss. And that will be, since his loss is actually minus, because it is exothermic, it is giving out. Then you will of course try with this, it will be less than that. This is the problem. I wanted to compare with this, nothing else. Constant pressure, you see, this is actually continuous, means open to atmosphere. This is a continuous reactor. So start. Take an analogy. So I don't care. Okay, you see, you take up this problem, so you write very nice. I'm going very quick, the solution. Okay, you want to, shall I remove this? Shall I remove this figure? Then I take this diagram here. Take this diagram here, okay? I'm taking the diagram here. What you are sending? 1500 Kelvin. Sketch. Which is not given, I'm giving you 1500 Kelvin. Lead liquid is produced. What is entering? Tell me. Oxygen plus nitrogen plus lead sulfide. Why oxygen plus nitrogen? Oxygen enriched air. Let us see, generally speaking, oxygen, nitrogen, exactly I write. What? Lead sulfide, solid stuff, good stuff, solid. You write solid, may not write. What temperature this is? These are entering 298. They are entering. They are sprayed actually by the some. Okay, they are forced into this with the blower. Blower maybe since solid is there, blower. Okay, gas is going and solid particles are going. Okay, getting into the furnace. This is the furnace. Then this is exothermic reaction. And why this temperature 1500? Because of the exothermic reaction. Fuel reaction is exothermic. Here also this is the fuel treating as a fuel, PBS. So this is fuel means no extra fuel extra. Okay, so no other exothermic source required. They are here. Okay, good. What is coming out is what? You tell me the figure SO2 N2 given to you 1500 Kelvin. They are exiting. This temperature, obviously, this temperature is exiting. And lead liquid also 1500 Kelvin. So these are the products. This stays back into the furnace and the gas leaves actually. What else I will write to you? Okay, what is the everything I have written for you. 1500 Q. What is the rejection? Some heat is lost, inescapable. Ideal condition consider 0. Perfect activity. Q is escapable. How much loss given to you? This is interestingly given 41.8 joule per mole of liquid lead. That you write. I'm very sorry. Kilojoule per per mole of liquid lead. Per mole lead liquid. Okay, this is a change. Quickly. So overall reaction, solution. Start the solution. The overall reaction. Let us see. Now you will easily follow. The overall reaction is what you tell me with me. Okay, I'm writing first, then I will explain you. Plus O2 plus XN2. These are the gas. You can write in bracket gas. Everyone knows nitrogen and oxygen are gas, but still to be purest, write this. Okay, beginners. have a, make a practice. You make a practice. It goes to what? Goes to what? Right hand side. What you know very well, Pb liquid will be formed plus SO2 plus N2. SO2 X is an X. I'll explain. X is the number of moles. X N2. What temperature? This is what temperature? This is what temperature? As you tell me, 1500 Kelvin. 1500. This is the overall sketch. If this line is okay, then nothing else. No one can stop. No one. Anyone. No one. This line. Just this line. And what to write at the, this is actually a what type of process? Constant pressure process. And of course, not only this, what is the other things here? Heat is liberated, not adiabatic. Adiabatic I am not writing because it's non-adiabatic. Okay, good boy. So please write. I am writing that. See, follow this. Call this equation big one. Big one. Okay, given delta H1. Okay, given what I am writing. Achha, given delta H1 is what? QP. Delta H1 is QP is minus 41.8. Acha, I'm sorry. I have to write. I write something. Clarify. Sorry, clarification. What is the question is given? You consider this. Is given here anything? Okay. Say, you follow this. PB liquid. 1 mole. Okay, 1 mole is given. Per mole is given. Per mole. Where? Per mole. 1 mole. Starting point. Follow. Starting point. You will not be confused. Lead. 1. Balance. 1 PBS, 1S balance 1 SO2, 1 O2 balance back O2. Nitrogen is the unknown guy X because we don't know. You have to find something though. X and 2 that gives the enrichment. Okay, that means it is 1. Nitrogen should be in typically air is what? Typically air will be 4 times. Oxygen, if air, it should be 4 nitrogen. If it is air, we don't know what is the enrichment. It will be, nitrogen will be here less than 4. Answer will be less than 4. I will give the answer here 1.56. This is the answer. This is the question. And last is the percentage. This is the last line. So it cannot be 4. So let us see what. We don't know. How shall I know? If it is 4, there is no enrichment. No enrichment is air. Repeat. 1 mole. Why 1 mole? Per mole here. Why shall I consider 2 mole? So you multiply 3 moles, 4 moles. No, 1 mole, sir. 1 mole liquid, keep it there. 1 balance PBS. The other day, some student actually asked me, Obhik, yours 1 year senior, and called me actually. So that it was ringing. He called me. Later on, I called back actually. Well, sir, some mass balance and heat balance, sir, do you have some actually? Can you help us? Help me? Yes, sir, something suppose, I don't know. So, well, mass balance actually, they didn't take this course with me. You are taking. Last year I didn't take, someone else maybe. So mass balance you automatically get from this concept mass balance. Balance 1 mole. So consider this 1 PBS S 1 SO2 1 O2. What is the O2 source? 1 to the mass it cannot be changed. Now nitrogen is actually value of nitrogen will decide the percentage enrichment. Okay. So you can say X would be your guess. You know X is 4. If it is 4 times, then it is just air. So enriched with this will be greater. Then this will be less in proportion. X will less. And other things are reaching. Good boy. So delta, this is okay though. Delta TP. Why this is constant pressure? I've written there. Constant pressure portion. Open to atmosphere, continuous. And this is how much the heating interaction involved? Minus 14. If it is perfectly adiabatic, it will be 0. Shall I write here? It would be 0 if no loss. Actually, if no loss, what is this value? If no loss. No heat is dissipated. No heat is lost to surrounding. What is this value? 0. Get back to the adiabatic flame temperature problem. All solved. Others are easier. So break up quickly. Break up and break up. So I'll give you the breakup. 1. Start. Okay. 1. Okay. 1. Start. Achha, I'm writing quickly. This will help me go fast. Lead sulfide S plus O2. Okay, do this. Both are 290. So what is the reaction? I am telling you. Follow this. Lead sulfate plus O2 is what? Lead plus SO2. This is exothermic reaction. Who else? Nitrogen doesn't participate. Lead sulfide, PbS plus O2 giving rise to Pb plus SO2, so 1, 1, 1, 1. Oh. This is a chemical reaction. Okay. So let me write is what? So I write here. Tell me. Not PbO. Never write PbO. That is the truth. Lead will be produced directly. Lead will be produced directly plus SO2. That is actually characteristic, thermodynamic characteristic actually in copper also. Those actually tend to form the metals. Actually, oxide is also actually react back with the lead sulfate forming lead plus SO2. This is their character, okay? So, but it's given to you. You don't have to know so much. So, lead oxide is no good. Lead is, you have given. Why? It is given in the problem. What is the product? Liquid lead and an SO2 mixture. So, why do you consider lead oxide? Unnecessary, difficult, complicated, erroneous. So please write what is the right hand side is what? PbS plus, Pb liquid plus SO2 gas. I tell you something here that will help you. What temperature? Same temperature. Chemical reaction, same temperature. Pb liquid, okay. Pb, I'm written Pb. Written, I wrote that. See, follow. I've written liquid, don't know melting point. You know 327 low melting, you don't know. Even you don't know. Right? Let's solve it. Solve the problem. No problem. It could be. Lead produced solid form, liquid form. Even after solid liquid, there is a melting point, enthalpy of melting, latent heat. That they all will address in the problem. That is its lookout. It says between 298 to 1500. This change in enthalpy is given, you follow me. Change in enthalpy. That covers if there is any phase transformation. You don't worry. If there is no phase transformation, this is the answer. If phase transformation included here, that is the lookout. Your point? Okay, no problem. Just give me 290, 1500, whatever. Lead 290 or lead 1500. If there is a phase transformation, there is enthalpy change, that is there. Means each enthalpy is greater than this enthalpy. Okay, so minus. What is minus? Data where go and data is where? Minus. Okay. So so this is first plus. Next is tell me what is the steps? First is reaction. Then take this to 1500. See right hand side. Take this to 1500 step by step. Lead liquid plus SO2 gas. Take 298. SO2 gas 1500. Now, one or two students have solved this problem. Tried very much. 3 students actually. Not the two years sitting here and another student also tried. Tried in the same direction. There is some little bit, okay, twist, but approach is very good. Good attempt. So I have given them marks. 6. I have given them. Okay, 1500, 50%. Very nice attempt. Okay. Very good. Third is what? What remains? Nitrogen. Let X moles of nitrogen is with this ratio. Yeah, X moles. Okay, third. Quickly, what is the X nitrogen? Right? Another line. 298 kya? Is X nitrogen? 1500 kya? Is it difficult at all? Shall I at this stage remove this right hand side? Shall I remove the problem? Naki? Okay. Shall I? This is no problem. No. Okay. Shall I remove this? Remove this. All remove. Oh, sorry. So quickly. Step 1. Tell me. Delta H1. You write first of all. Delta H1 is what? Tell me. Delta. What is overall? 1. Is what? Comprised of these 3. Are you convinced? Add 3. Get that. So first you write this. So delta H is nothing but delta H1 plus delta H2 plus delta H3. 2 in one step. I have done it in one step. One step I am doing. I'll follow it. Delta H1 is by the way how much? You have already written somewhere. Is what? Tell me. Minus 41. Write that. So write minus 41.8 kilojoule per mole. You don't have to write because 1 mole you have considered. So just delta H1. Tell me one by one, quickly. Tell me step by step. What is delta H1? See, this is chemical reaction means formations will come into picture. What are the formations? Difficulty. Okay, just. I'm done. I'm 5 minutes. Just give me 5 minutes. I'm done. 3, 1, 2, 3, and solve. One is what? Tell me. Now you participate. Given this breakup, what is this? Sukanto, what is the delta H1? See the reaction. This is a chemical reaction. These are the heating group. This is the heating type. These are Sabbosachi, I have given you the answer paper too. Yes. Formation, chemical reaction, heat of reaction is in terms of formations. In terms of formation. Yes, tell me, you tell me. What is the formation? First one? Delta H. Who's SO2? Delta H. H or H0, whatever, SO2. And this will consider? No. In principle, you will not consider at all because this will cover. Minus. Write this out. Plus delta H2. Delta H2, I'm writing for you. Plus delta H2. Delta H2 is what? Please tell me. What are delta H2? What are the stops? 2 stops. And together, three stops. Okay? They are moving from 298 to 15, one by one. PB liquid or PB. PB, okay? PB liquid or what is this? I'm very sorry. PB here. PB wrong. It is wrong here. Okay? PB liquid 298. Very sorry. I'm very sorry. I'm very sorry. What is this? 298 it is melting point is 600 Kelvin. Okay. PB, so don't worry about this part. This part, don't worry. And then what you will write here? Again solid, please correct this. Please correct this. And goes to liquid, okay? But you don't care. It is lead. It is lead. What is this? Follow one by one. This lead 298 to lead 1500. What is the answer? Answer, tell me. 1500 minus H298 for lead. Happy? For the first one. See, one by one. Then SO2. Same SO2. Plus, we continue. Plus H1500 minus H298 for SO2. See, the data is per mole. And only how many moles are involved? 1 mole per mole. Okay? This is different. Third is what? Third who? This is over. This 2 over. Third is similar. X nitrogen. Plus, you write X nitrogen. Again, H1500 minus H290. What is this? You make your task easier. Otherwise, CPDT. CP is A plus BT. CT. Integrate. Get the result. That is done for you. Either this or heat capacity will be given. I gave heat capacity, you got this. Okay. What is the answer? Suppose you don't know. This is not given. This is not given. Not given. So what will do here? This step. What will you do? CP dt. Suppose no phase change. It fast. Okay. This step. No phase. CP lead dt from 298 to 1500. CP or enthalpy. CP dt. Okay. Constant pressure. CP dt. Okay. And if phase transformation, then a third bar activity. Here easy. Sulfur dioxide. What is this? What is this value? CP for sulfur dioxide. Here is CP SO2 dt integration from 290 to 1500. 290 to 1500. And CP must be given in A plus BT form. You have solved many problems. So over. This is H2. What I wrote here? H298. For whom? X times. For whom? Nitrogen. So just substitute this value. If you do this, I'm writing quickly, very quickly. Follow with me. Okay, follow with me. Okay, minus 297. You check. If I make any mistakes, plus 94. Down. 297 and minus plus down. Plus H first term. Lead how much? 40. Oh, it's over. The second is what? Sulfur dioxide. Where it is? Here, 62. Last term is what? Tell me. You tell me. Sugarland. What shall I write? X into 100%. X into 38. 38x. Can't you solve x? Still, top is minus 48.8. You do yourself. Or x is, I give you the value. I'm going you check this. This will come like finally by 38. This is your answer actually. How many moles of nitrogen you charge with 1 mole oxygen? 1.56 mole, not 4. 4 is air. Less than that means oxygen is enriched. This is impoverished. Okay, this is actually nitrogen is actually not in opposite. Okay, enriched. Okay, that is enriching, and this is actually impoverished or okay deficient. Actually, yeah. So tell me now. Answer. Anyone can answer. What is the percentage oxygen in the input? This is the question. Percentage oxygen. Let me write in the inlet gas mixture. Input or inlet gas mixture. This is the last line. Tell me. Acha, one of you should try. Any of you should try. Okay. Somo, since you have solved this problem, what is the answer? Percentage oxygen in the inlet gas mixture. X is found. Ah. Ah. 1 by? Ah. 1 by. Oxygen is percentage. Oxygen is how many? It's inlet. 1 mole, sir. And total is oxygen nitrogen is what? X plus 1. 1, good, very good. 1 by x plus 1 into, will you? Answer is 39.1% answer. The end. Thank you very much for giving me time. Thank you very much. With this, actually, we have completed this. It's okay, time is okay. I'm calling him, actually, I'll let you know. So with this, we have completed the solution, and today, actually, we call it a day. Okay. First of all.